Section 5.1. So these are some identities that you want to memorize. Cosecant is 1 over sine, secant is 1 over cos, cotangent is 1 over tan. These are all the reciprocal identities. Then you have the ratio ones, which there are 2 of. And then you got the Pythagorean identity and the 2 variations of it. And the Pythagorean identity can also be solved for sine squared or cosine squared. So our first example, we're trying to show that the left side is equal to the right side. In this case, I would recommend working on the right side because we can distribute. So let's distribute. So the right-hand side is going to equal to sine of x times, I'm going to change that to 1 over cosine of x because that's secant, plus sine of x times cotangent, which I will change to cosine x over sine of x. And as you can see, these signs can cancel, and we're left with sine over cosine plus cosine. And sine over cosine is tangent by definition, and that is equal to the left-hand side. For the second example, in this case, I would also work on the right-hand side. For this one, you want to, right-hand side, you want to rewrite, but we're going to use the fact that sine squared theta is equal to 1 minus cosine squared theta to rewrite that as 1 minus cosine squared theta over 1 minus cosine theta. And we know that this is a difference of 2 squares. That's a perfect square, and so is that. So we can write that as using our formula of 1 plus cosine theta, 1 minus cosine theta. That's how you factor the difference of 2 squares over 1 minus cosine theta. And now, as you can see, these factors cancel. And that'll leave us with 1 plus cosine theta, which is the left-hand side. Let's look at the homework. So let's skip down to number 4 on the homework. So we have to prove that the left side equals the right-hand side, and they guide us through. They're starting us off with the right side. Well, it looks like what they did is they split this up into 2 separate fractions. That fraction minus that fraction. So this would be, the missing term here would have to be sine squared theta. And for the next one, it looks like they canceled one sine with one sine, and that leaves us with just 1 sine over cosine, and that should do it. For number 5, the same thing. We're showing they're starting us off on the left-hand side, and then they're multiplying the top and the bottom by the same factor. In this case, the conjugate of the numerator, so secant theta minus 1, secant theta minus 1. Whatever you do to the bottom, you must do the same thing to the top. All right, and now it looks like they are going to, let's see what is happening now. So looks like what's happening is that we have secant times secant. Okay, so they just FOILed this out, and you get secant squared minus 1. So that's secant squared minus 1. The minus 1 is already there for us. All right, and then it looks like they're going to do the, let's see here. In this step, what's happening now, looks like we have secant squared minus theta. Well, that's an identity. Secant squared minus theta is, if you subtract 1, you get secant squared minus theta is equal to tangent squared. So that's going to be tangent squared. All right, and that does it. For number 6, it looks like they want us to do it from scratch. So let's work on the left-hand side. And it's over here. Let's work on the left-hand side. All right, so far we have this expression on the left-hand side. I'm going to rewrite this cotangent as cosine over sine. Then what I'm going to do is I'm going to multiply top and bottom by sine, because I don't want that fraction here. So I'm going to multiply top and bottom by sine of x. Sine of x. The bottom, I'm going to distribute the bottom. So when you distribute the bottom, the top I'll just leave the sine x in the front. And the bottom, if I multiply, I get sine x times cosine x plus, and then these two end up canceling, so I just get plus cosine of x. Since I want to get a tangent and I have a sine over, I want the cosine, sine over cosine to get the tangent, that means I'm going to factor out the cosine. So let's factor out the cosine from the denominator. And that leaves us with sine of x plus 1, which is perfect because now these cancel. And that gives us sine of x over cosine of x, which is tangent of x, which is equal to the right-hand side. All right, the next problem looks like, all right, so what you can do here, this is a difference of two squares as well. So it's going to be secant squared minus tangent squared times secant squared plus tangent squared. That's a difference of two squares formula. And then for the next step, let's see what they did next. It looks like they multiplied this. So that's going to be, oh, I'm sorry, they didn't do that. It looks like they canceled this out and this out. And so you're just left with secant minus tangent squared. All right. And for the next slide, this says prove that the following statement is not an identity. So we can pick any counterexample. Let's see what we can do. Let's choose, how about 30 degrees? The sine of 30 is 1/2. So 1/2 squared is 1/4. The cosine of 30 is radical 3 over 2. Radical 3 over 2 squared is 3 over 4. On the right side, the sine of 30 is 1/2, and the cosine of 30 is radical 3 over 2. So this becomes the square root of 1, which is 1. And this becomes 1 plus rad 3 over 2. So clearly, these two sides are not equal to each other. Therefore, that's a counterexample. So this is a counterexample. This angle shows that these two sides are not equal. All right, for the last problem, they want us to determine whether this is an identity or not. If it's not, then we need to find a counterexample. If it is, we should prove it. See if we can prove this one. I have a feeling it's not, because secant is 1 over cosine. And then if I put a 1 under and I combine these two, I should get cosine times cosine. So now I have 1 plus cosine squared x over cosine. And that does not look like it's equal to the right side. So I think what we should do is find a counterexample. How about we do theta, or x equals 45. All right, so secant of 45 degrees would be the reciprocal of radical 2 over 2, which is 2 over radical 2, plus cosine of 45 degrees is radical 2 over 2. Tangent of 45 is 1, and sine of 45 degrees is radical 2 over 2. So as you can see, these two sides are not going to be equal because these two things are equal. So if you add this to this, it's not going to equal that. So this is a counterexample. 45 degrees shows that the two sides are not equal.